And finally, one final way to look at this model and to look at this process and to understand why we have to enumerate or sum or integrate in the prediction stage, but we don't have to do this in the observation stage, is to think about this problem in the context of the Bayesian network inference that we're doing, and in terms of the evidence, the query, and the hidden variables. So the evidence we have, as we said, you can see it down here, the evidence we have is a stream of couples, a stream of two values at different times. We have the control and the observation, control, observation, control, observation. So we have these couples coming in as a chain of events, and this is the evidence in the Bayesian network framework. And then we have the query, which is our updated belief at each stage. So it could be our updated belief here, what we call the belief star, or it could be our updated new belief, and this would be the query. So if we look at this in the Bayesian network setting, we can see that we have our query and we have our evidence, and then the one thing that is the hidden variable, which we only have a probability distribution over and we don't have a specific value, is the previous belief. So if this is, again, our syllable example, the previous belief. So now let's look first of all at the, if it was at the stage where we're doing the observation. So the Bayesian network that we're interested in is this one here. And here, because we have a given evidence, we have a very specific evidence that we know about, and we want to know the value for each possibility of our query, all we have to do is to go to each possibility, look at our prior, and multiply it by the probability of the observation given the prior. So there's no enumeration or summing necessary because we are just looking at one query variable and one evidence variable. But if we're looking at this other stage of the filtering, the prediction, we have a more complicated or slightly more complicated network, and this is this network here. And here we have one evidence variable, so we know what the control is, and this is given, so we know the value of this variable. It's a specific value, and we want to know for each value of our query variable. So for each one of those, we want to know what the probability of it is, given that we know this this variable. But we still have to enumerate over this hidden variable, which could be in one of any of those states that is given the probability. So therefore, when we ask about a specific value for xt, we have to go over each one of the value of the possible values. That could be a sum, it could be an integral, each of the possible values of the hidden variable, and for each one of them ask, if it was this one, which probability, 1/4, what would be the probability that we end up here? Plus, if it was this one, so we have 1/2 probability that we're here, what's the probability of ending up here, etc., using this particular transition model here. And just as we saw in any kind of Bayesian net inference, we have to enumerate over our hidden variables, whereas we can sort of slice out or assume the specific value of the evidence value that we have. And since these ones are known, so they're either the control that we are controlling or the evidence that we're actually seeing, we don't have to enumerate over these. And when we're looking at the evidence stage, which only looks at these two variables, we don't have any hidden variables to enumerate over. When we're looking at the prediction phase, we do have this hidden variable in the Bayesian net sense of the word that we need to enumerate over.